Welcome. Let us solve the question 6.4.2 of Arfken, Weber and Harris Mathematical Physics. Okay, so the question asks us to prove a matrix, or give a certain given matrix is Hermitian if it satisfies two questions. Okay, so we have to prove or two conditions to say. The first is wait. We have to prove matrix is Hermitian if we have all eigenvalues are real and eigenvectors are orthogonal. Alright, so we'll start with the question. So from A we form a diagonal matrix AD, or let me call this as A prime, with diagonal elements as eigenvalues. Alright, now the conjugate of the eigenvalues, or rather say the diagonal matrix transpose conjugate is, or what do we call this as, a Hermitian conjugate. Hermitian conjugate. We first take transpose and complex conjugate, that's the Hermitian, is equal to matrix A prime itself. So the reason are, first it's diagonal, and second it's all elements are real over here. Alright, so this is one thing, so let me call this as 1. Okay, now it's not orthogonal over here, it's orthonormal. So there's a huge difference between orthogonal and orthonormal, and the difference is, if let's say you have two orthogonal vectors u and w, so their inner product would be 0 and the inner product of the vector with itself would be some constant. This would be some constant, say A, this would be some constant, say B. But if they are orthonormal, then u and with the inner product with themselves would give us 1 rather than some other constant. Okay, now our eigenvectors are orthonormal. So from this we can form a matrix U which has these column elements as the eigenvectors. Okay, so this is x1, then there is x2, similarly it goes up to xn. Alright, these are the column vectors that we have. Okay, so I'm just writing over here where column are eigenvector. All right, so now we know that this matrix, such matrix that we form from the eigenvectors, is unitary. So since it's unitary, then the diagonalized form of matrix A is U dagger into A into U. Okay, now I'm multiplying both sides by U and U dagger in this manner. A prime U dagger equals to A. Okay, now I will take the complex conjugate of this particular matrix A. So my A dagger becomes U A prime U dagger, the whole dagger. It's U dagger dagger, A prime dagger, U dagger. Okay, and that leaves me with U A prime U dagger. So actually this is A prime dagger. Okay, but from 1, that over here we have already proved that A prime dagger is nothing but A. So we can write this like this. Okay, now we put the value of A prime. We put the value of A prime from here into this matrix and we get U dagger A U dagger, which implies which is equal to A, and finally we get A dagger is equal to A. This is nothing but the definition of Hermitian matrix. Okay, so we can finally conclusion A is Hermitian matrix. I hope the solution is clear. Thank you for your time.